This is the group project of Team Sparta. Today we are doing a whiteboard illustration of externalities and how they affect people. The title of this project is The Story of Town Sparta. Now, this video was inspired by a TED Talk that you showed us earlier in the quarter that was about externalities and demonstrated on the whiteboard. We thought this was a great idea and we are attempting to replicate it. To illustrate the definition of an externality, we're drawing a stream, and surrounding this stream is a town. A part of the definition of an externality is that the damages must accrue to people. As the town grows in size, more people can possibly be affected by a damaging source. Upstream, there is a factory, and this factory produces widgets for the town downstream. However, there's a caveat with the factory's production. It is unable to produce widgets without emitting some sort of pollution. This pollution has the potential to harm the people downstream. As the population grows in the town, that is more possible people that can be affected by the factory's damage. The number of people affected by the factory's damage is what quantifies the y-axis on the marginal damage curve. As the town develops, so does its need for the open access resource of water. This public good not only provides the residents with their municipal usage, but also for their production, illustrated by a farm. The water that is provided by the stream is what is considered a public good, meaning that A, it is non-rivalrous, and B, it is non-excludable. When it is non-rivalrous, that means that one person's consumption of the water will not affect another's. Additionally, it is non-excludable because no one can buy the stream and monopolize it for themselves. As the factory produces the widgets for the Sparta town, it emits pollution. For every unit of production, aka every widget it produces, it will subsequently produce pollution, and that will be released into the water. The people of town Sparta consume the water, and subsequently they consume the pollution emitted by the factory. This pollution is illustrated by the red ink. As more people consume the water, they also consume more pollution. This pollution has damaging effects, and these effects can be monetized. Once again, as the population increases, so do the damages that accrue to these people. As the factory produces more pollution, more people are affected, which thus explains the increasing slope on a marginal damage curve. The curve is calculated by the respective x and y coordinates on the marginal damage graph. The x-axis is the units of pollution emitted by the factory, while the y-axis is the monetized value of the people affected by that pollution. For instance, when the factory increases its production of widgets to such a level where the emittance of pollution is severe enough to hurt someone, these damages can be monetized by the cost of doctor visits, prescription medication, or severance packages. The pollution emitted by the factory has caused an uprising in town Sparta. At this level of production, the people have a willingness to pay to abate the pollution emitted by the factory. The people of town Sparta approach City Hall. They demand change. At this point, it is the factory CEOs versus the townspeople of Sparta. The angry people of town Sparta want change. They want clean water, and they want the factory to stop producing emissions at such a high level. In an economic scenario such as this one, the factory CEOs and the angry townspeople will compromise to a level where the factory produces emissions at a socially efficient level. The factory and the townspeople have come to an agreement. The factory will implement new technology that allows them to produce widgets at a rate which causes less emissions than before. The factory's implementation of this new technology will significantly reduce the marginal abatement cost curve. This means that the cost to abate the emissions polluted by the factory will be decreased. This new technology is in the form of a water treatment facility. This facility will filter the stream's water and emit water that is less polluted than before. It will not remove all of the pollutants, but only to a level where the overall social costs are minimized. At this level, this is the intersection of the marginal abatement cost curve and the marginal damage curve. If the water filtration system was to remove pollutants at any other rate, this would be a socially inefficient level. This means that the total damage and the total abatement costs would not be minimized because any other shift would cause a disproportionate increase in the marginal abatement cost or the marginal damage. So, the townspeople of Sparta and the factory have come to a mutually beneficial agreement. The factory is allowed to produce at a rate where the marginal damage of producing one more unit of pollution is equivalent to the cost to abate that unit of pollution. Well, that is our presentation. I hope you enjoyed it as much as we did.